coordinate bond, covalent coordinate bond. This covalent coordinate bond is a special type of covalent bond because in covalent bond, the bonding pair of electron, that is one pair of electron is mutually shared by two bonded atoms. In that pair, one electron is contributed by one bonded atom and another electron is contributed by another bonded atom. Out of one pair, both the bonded atoms will contribute one electron each. But in the case of covalent coordinate bond, here one of the bonded species, it may be an ion or a molecule, it will contribute a pair of electron, and other species which is involved in the bonding, it may be a molecule or ion, will contribute an empty orbital. Both will share the pair of electrons, and the bond thus formed between those two species is said to be a covalent coordinate bond. Remember, covalent bond is formed between two atoms. Covalent bond is formed between two atoms to form a molecule. Covalent bond is formed between two atoms to form a molecule. Whereas covalent coordinate bond is not like that. Covalent coordinate bond will be formed between two molecules or between one molecule and one ion or between two ions. Of course, when bond is formed between two ions, you may think that it may be an ionic bond. But in some cases where the difference in the electronegativity is not more than 1.7, in such cases, there is a possibility of formation of covalent coordinate bond. Particularly in D block elements, we will observe this type of covalent coordinate bond. That is, with a positive metal central atom with a negatively charged species. Actually, that metal atom will involve with bonds, with covalent bonds with other molecules. So, whatever it may be, covalent coordinate bond is formed between two molecules or one molecule with an ion. So, the conditions for the formation of this covalent coordinate bond is one bonded species and one species which is involved in the bonding should have a non-bonding pair of electrons in the valency shell of its central atom. Non-bonding pair of electrons in the valency shell of its central atom. For example, if we take NH3, in NH3 molecule, the central atom is nitrogen. The central atom nitrogen atomic number is 7. Its electronic configuration is 1s2, 2s2, 2p3. So in the valency shell, you will have 2s2 electrons, one pair of electrons in 2s orbital and 3 half-filled p orbitals. Now this nitrogen will undergo to sp3 hybridization. In detail we discussed in the sp3 and VSEPR theory, we will discuss the structure. 4 hybrid orbitals will be formed. So these 5 electrons when enter into the 4 orbitals, 3 orbitals are half filled with 1 electron each and other orbital is filled with a pair of electrons. That pair is said to be non-bonding pair. Now this half-filled sp3 hybrid orbitals will overlap with 1s orbitals of hydrogen to form NH sigma bonds. Such 3 sigma bonds are formed in NH3. So in NH3 molecule, 3 sigma bonds are present between nitrogen and 3 hydrogen atoms, and a pair of electrons will form present in sp3 hybrid orbital. Now this sp3 hybrid orbital is in a position to form a bond provided if any orbital is empty. So those molecules or ions which are having empty orbital can form a covalent coordinate bond with this. When empty orbital is available, any metal atom, any molecule, if its central atom has empty orbital, such molecules can accept a pair of electrons, or any ion which is having an empty orbital, it can accept this pair of electrons. So here we have a molecule called BCl3. In BCl3, central atom is boron. Boron atomic number is 5. Its electronic configuration is 1s2, 2s2, 2p1 in its ground state, but on excited state it is 2s1, 2p2. It means in the valence shell we have 1 electron in s orbital and 2 electrons in p orbital. Now it will undergone to sp2 hybridization to form 3 sp2 hybrid orbitals which are planar trigonal shape, and each orbital is half filled with 1 electron. So these sp2 hybrid orbital form 3 sigma bonds with 3 chlorine atoms to form a BCl3 molecule. Now we have a p orbital which is empty. Here we have an empty p orbital. It is perpendicular to this plane. So now in BCl3 we have an empty p orbital. This is empty p orbital. So this empty p orbital is in a position to take part into the bonding provided other species is able to donate a pair of electrons. Now when NH3 and BF3 are in contact with each other, NH3 with a lone pair of electrons, BF3 with an empty orbital, when came in contact with each other, they form a covalent coordinate bond. This is BF3. So this is NH3. Here NH3 is donating a pair of electrons. That's why we'll show that bond like that with a arrow indicating the donor to acceptor. So here you will have a covalent coordinate bond between nitrogen and boron. కనిపిస్తుందా అది? Now we can observe the same type of hydrogen bond between NH3 and H plus ion. H plus ion will have one empty 1s orbital. When NH3 is nearer to H plus ion, NH3 will donate a pair of electrons to H plus ion, and H plus ion will donate that empty orbital, so that a covalent coordinate bond is formed between nitrogen and hydrogen to form NH4 plus ion. In NH4 plus ion, we'll have 3 normal covalent bonds and 1 covalent coordinate bond. So this is the formation of covalent coordinate bond. Covalent coordinate bond is a special type of covalent bond in which one of the bonding species will contribute a pair of electrons and other bonding species will contribute an empty orbital, and both the species will mutually share the pair of electrons to form a bond which is known as covalent coordinate bond, and this bond is also called as dative bond. Covalent coordinate bond is also called as dative bond. Here one species will donate a pair and other species will contribute an empty orbital and accept the pair of electrons.